Hey guys, here is my video for problem number 2 from the packet. So I'm gonna solve it the way that the solutions guide solves it, and then I'm gonna go on and talk more about some different things that you can do with this problem. So the first thing we want to do always is to mark our diagram. So when we read the problem and we see, oh, I have somebody here that wants to say hello. This is Zeus. He likes to come and hang out whenever I'm doing things. So, hey Zeus. So in the problem, we see that CD bisects angle ACB. So we want to be able to look and follow ACB, and then CD bisects it. So that's bisecting the angle. So when we mark it, we see we have two angles right here that are equal to each other. So this is in the problem, this 42 degrees, but that's not the two angles that they're talking about. So then we have some information. AB equals BC. So AB is this segment right here, and it's equal to BC. So I'm just marking those as equal, and we see that ABC, because we have two legs that are the same, are an isosceles triangle. And then BEC, so that's the one that's already marked. BEC is 90 degrees, so it gets a little right angle marker. And DCE is marked as well. So that's 42 degrees, and that's DCE, so that whole thing is 42 degrees. Now, the thing that we're looking for is angle A, and that's allowed to have a one variable name because it's the only angle right there. So that's, I'm going to put a question mark there. That's the thing that we're looking for. Now, in the solutions guide, they mark, instead of just these angle equivalencies, they actually say that those two angles are equal to each other, and they're going to call them both x. So that's kind of a key to solving the problem, really. So the other key that they mention is that since ABC is an isosceles, this whole base angle here is made out of 2x. So angle A must also be 2x because they have to be equivalent on the base angles of an isosceles triangle. So if I just pulled triangle ABC out of the picture, and so that way we wouldn't have all the other things to sort of distract us, this angle here would be 2x, and this angle here would be 2x. So that kind of helps me know that if I can figure out maybe what angle B is, then I have enough information to find these other angles. So that's where they look to find the solution. Okay, so they're going to use triangle ACE. So now I'm going to look at triangle ACE, and I know that the three angles of a triangle always have to add up to 180 degrees. So basically, angle A plus angle ACE, that's this big one at the top, plus angle E, all three of those equal 180 degrees. Now I'm going to go through and I'm going to substitute any information that I know. So I'm going to start out, angle E we know is 90 degrees. Angle ACE, you can see that it is made out of, and this is the angle addition postulate. If I add one of these little x's plus this 42 all together, that's going to make angle ACE. So I'm going to replace that, substitute it with an x plus 42. And then last but not least, we determined over here that angle A is really the same as 2 x's. So I've substituted for each of the angles in my big triangle ACE, And now I have an equation that is true, and I know how to solve it. I solve it by combining like terms. And let's see, I needed a plus in there, and so 42 plus 90, that's 132, equals 180. And then I'm just using my equation solving to get my x value. So 3x is 48, and so 1x is 16. So 1x is 16. That's not really what the problem was looking for. The problem was looking for angle A, and since angle A is 2x, I can go ahead and substitute my solution in there, and I get angle A is 32 degrees. So that is a very good and eloquent way to solve the problem. If that makes perfect sense to you, you can go ahead and pause the video and leave it at that. I'm just going to play around with this triangle a little bit extra here and see if there's any other way that we could have approached the problem. So one thing I noticed is with this 42 degrees right here, I could look at triangle CDE, and using that I could figure out angle D, because in triangle DCE, I could say that 42 plus 90 plus angle CDE equals 180. And then I subtract my 42 and my 90 from 180. And so let's see, 42 plus 90 is 132, and that gives me 180 minus 132. I get angle CDE is 48. So if I know that's a 48, then I know that is an exterior angle. And so I know that my exterior angle equals the sum of my two remote interior angles. So I could write an equation that, let's see, 48 is my exterior, and it equals 2x plus x. So 48 equals 3x, divide by 3, and I get x equals 16. So that, and 2 times 16 is 32. That's another theorem that we learned about that could help you figure out what angle A is. And then let's see, is there anything else? I mean, I could use a straight line theorem in a linear pair. And so I know 180 minus 48 is 132. So I could get my 132 here, and then I could write that same equation again. 132 plus x plus 2x equals 180. So I can get that equation in a few different ways. So if you worked it another way, there's lots of ways to approach that problem. That is problem number 2, and thank you for watching.